Module 1, Lesson 18, Looking More Carefully at Parallel Lines. So again, this lesson is going to have a lot of review in it, nothing really new. Parallel comes up in our vocabulary again. Parallel lines lie in the same plane and do not intersect. And segments and rays are parallel if the lines containing them are parallel, and don't forget our symbol is read as parallel to. And you remember a transversal from last topic. It's the line that intersects two or more coplanar lines. So we have lines L and M, and they are intersected by transversal T, and they form special angle pairs. And the two that we are going to be focusing on in this section are our corresponding angles. Remember, corresponding are in the same place. And our alternate interior angles, which are non-adjacent interior angles on the opposite sides of the transversal. So we have our examples here of corresponding and alternate interior. Alternate interior are opposite inside. The major concepts in this lesson are ones that we've already seen. Two lines are parallel if and only if alternate interior angles are congruent. Now this is a new way of writing for us. This is called a biconditional, and a biconditional is true forward and backward. So we can separate this into our two well-known statements here. Our conditional says if a transversal intersects parallel lines, so if we have parallel lines, alternate interior angles are congruent. And we have our converse that says if alternate interior angles are congruent, then our lines are parallel. So a biconditional simply states both our conditional and our converse are true. In this lesson, we are going to learn to construct parallel lines using a rotation and alternate interior angles. And I'll do an example of this at the end on our little geometry app. And so what we do is we are given a line and a point not on that line, and we want to draw a line parallel through that. So we choose a point A, find our midpoint, and then we go on and choose a point B and draw the line through point C, because what we're going to do is rotate our line L about this point C, and so we want to end up over here, and we just use our compass to rotate 180 degrees, and we draw our line because that's 180 degrees. We end up with two congruent angles, angle BAP and angle QPA. And if you notice, those angles are alternate interior angles, and if alternate interior angles are congruent, then our lines are parallel. Some more review. Remember our converse of the corresponding angles postulate says that if corresponding angles are congruent, then our lines are parallel. The converse of the alternate interior angles theorem says if alternate interior angles are congruent, our lines are parallel. The converse of the same side interior angles theorem says if same side interior angles are, remember the S's, supplementary, that means they add to equal 180 degrees, then our lines are parallel. Same side interior angles are the ones that are different. And our converse of alternate exterior angles theorem says that if alternate exterior angles are congruent, then our lines are parallel. And don't forget, our friend, the parallel postulate here says that we can, through a point not on a line, we can draw one and only one parallel line to our given line. And that's what we just did with our latest construction. Proofs are back. Yay! So we are going to be proving lines parallel again using our converse of our special angle pairs. And so here is an example for you, the proof of the converse of the alternate interior angles theorem. We are given angle 4 is congruent to angle 6, and we want to prove that line L is parallel to line M. So we use our define explore, use our ideal method. We know that 2 and 4 are vertical angles, so those are going to be congruent, and 2 and 6 are corresponding angles. And now we have a way to relate angle 2 and 6 going through 4. That would be our transitive property. We're always looking for those common parts. And that will let us use the converse of the corresponding angle postulate to prove that when alternate interior angles are congruent, our lines are parallel. Remember, alternate interior angles is a theorem which has to be proven, and corresponding angles are a postulate which is accepted as fact. That's why we can use it to prove this theorem. So we simply write our statements. We are given angle 4 is congruent to angle 6. We use vertical angle theorem to show that angle 2 is congruent to angle 4. We have our common angle there, so we can cut out the middleman and say angle 2 is congruent to angle 6 by the transitive property of congruence, and line L is parallel to line M by the converse of the corresponding angle postulate. Now that we have proven that this is true, anytime that we see our alternate interior angles are congruent, we can automatically say that our lines are parallel because we have now proven our theorem. It's very much the same for our last proof here, which is the converse of the alternate exterior angle theorem. So we know 1 and 7 are congruent, and we want to prove our lines parallel. Well, how can we connect 1 and 7 with things that we know? Well, we could go 1 and 3, which are vertical angles, because 3 connects to 7 as corresponding angles. So this is one option here. Or we could go angle 5 and 7 are vertical angles, and then 1 and 5 are corresponding angles. So it doesn't matter. I chose to go 3 to 7. 1 to 3 and 3 to 7. So I simply crossed out these. I don't need those. I'm just going to use the transitive property because angle 1 is common to both of these, so I can relate angle 3 and angle 7, which are my corresponding angles, which is what I want to use. So this theorem looks very much like the last one. I know 1 and 7, 1 and 3 are vertical angles. Cross out the middleman there and say that angle 3 is congruent to angle 7 by the transitive property of congruence. And once I have 3 and 7 related, those are corresponding angles, so I can prove that my lines are parallel by the converse of the corresponding angle postulate. And once again, now that I have proven this theorem using my known postulates, I can use it in the future. Anytime I see 1 and 7, I can say, well, those are alternate exterior angles. They are congruent. Therefore, my lines are parallel. So some good stuff here, a lot of review, back to some proofs, and a new way to construct parallel lines using 180-degree rotation. We are going to construct a line perpendicular to our given line L here, and it's going to go up here through point P. And we are going to do this by using a 180-degree rotation. So the first thing we need to do is to choose any point on our line, and I'm going to choose a point right here and call it point A. And we need to draw segment PA. Line PA. So what we have done is created an angle right here, and we are going to rotate that angle around this way 180 degrees to create our parallel line. To do that, we need a point of rotation, and that needs to be the midpoint of our segment here. So you can either use a ruler or a compass to find the midpoint. And I like to just use a compass here. We've got going to find our perpendicular bisector. Just come around this way, draw our perpendicular bisector. And that's an easy way to find our midpoint, which we are going to call point C. So now we have an angle and a point of rotation. What we need to do now is to find another point on our line, and we'll just put that right here. We'll call that point B. And now we draw line CB. And what we are going to do with this is we are going to use this distance right here and rotate it 180 degrees to over here. And so we are just using length CB as our radius, and you can see that it's going to end up here because we're just measuring a distance. So I'm going to draw my circle C, radius CB, and where my circle intersects, where circle C intersects line CB, right here, that's our point Q. And what that's going to let us do is to draw line QP, which we can now label L prime. So I took my angle here and rotated it up here. I took segment AB and rotated segment AB up here to become QP. So these two lines are going to be parallel because of a 180-degree rotation. So because of our rotation, angle QPA is congruent to angle BAP, and by the converse of the alternate interior angle theorem, do you see those are alternate interior angles? We can say that line L is parallel to line L prime. So another way for us to construct parallel lines.